One mole of a substance is Avogadro's number of objects or particles. Avogadro's number is just a huge number, 6.022 times 10 to the 23, right? A very, very large number. This is because these atoms and molecules and particles are so small that we can't measure them unless we measure a very large amount of them. And then we can weigh them in grams in the laboratory. So 1 mole of a substance is 6.022 times 10 to the 23 objects. So this could be atoms, molecules, or ions. It could be formula units. It could be particles, electrons, protons, whatever it is you're talking about. So, for example, 1 mole of oxygen atoms is Avogadro's number of oxygen atoms. And the way that we use this is as a unit conversion factor. So another way to write this is 6.022 times 10 to the 23, Avogadro's number, atoms of oxygen per mole. And we'll use that as a unit conversion factor if we want to convert between moles and atoms. And this is what is known as Avogadro's constant, since it has units, and the units are per mole. Atoms is just something that we insert to keep track of what it is we're talking about. It could be atoms, molecules, ions, whatever it is. And you might see Avogadro's constant written as capital N subscript A. So how do we use this? Well, 1 mole of an atom is its atomic mass in grams. And this is what we call the molar mass of an atom. So we may want to convert between grams and moles. So the molar mass of an atom is its atomic mass from the periodic table in grams. So we could say that 1 mole of silicon, if we look on the periodic table at the bottom of the square, it says 28.09 grams. So 1 mole of silicon is 28.09 grams. If you're talking about 1 atom of silicon, it weighs 28.09 atomic mass units, or AMU, right? And so if we're talking about a large collection of those atoms, then we use grams per mole. And we can write this as a unit conversion factor. So this becomes 28.09 grams per mole. And that's how we'll use this. And this is often the first step in many chemistry problems. So let's say that we have 5 grams of silicon. Well, let's convert that to moles. We've got 28.09 grams. We want to divide by the molar mass, since we want to cancel out grams and get moles. And if we do that calculation, we get 0.178 moles of silicon. And what if we wanted to find out how many atoms that is? So this is why we convert to moles first, because then we can use Avogadro's constant. The units are per mole. 6.022 times 10 to the 23. Let's use atoms again this time, per mole. And we get 1.07 times 10 to the 23 atoms of silicon. So that's how we would convert from grams to moles, and then from moles to atoms. And that's for an atom by itself. What if we wanted to look at a molecule or a compound? So 1 mole of a formula is its formula mass in grams. And a lot of times we call this the formula weight. So for instance, the formula mass for sodium bromide is the sum of the atomic masses. So we take sodium's atomic mass, 22.99 grams per mole, add that to the atomic mass of bromine, 79.9 grams per mole, we get 102.89 grams per mole. Now that's the mass of a sodium bromide formula unit. So remember, for ionic compounds, we call them formula units. For covalent compounds, we call them molecules. So what can we do with this? Well, if we have 5 grams of sodium bromide, we can find out how many formula units we've got. So the first step is to convert to moles. Divide by the molar mass again. 102.89 grams is 1 mole of sodium bromide. And then we can multiply by Avogadro's constant. And this time we're going to put in formula units per mole. So we get 2.93 times 10 to the 22 formula units of sodium bromide. So that's how we would find the number of formula units. You would do the same thing for a molecule. Take it one step further, and let's find out how many sodium ions are in 5 grams of sodium bromide. So if we have 5 grams of sodium bromide, first thing we always do, when in doubt, convert to moles and see where to go from there. So 1 mole of sodium bromide is 102.89 grams. Grams cancel out, now we're in moles. And for every 1 mole of sodium bromide, you have 1 mole of sodium ions, right? Since each formula contains 1 sodium ion. If there were 2 sodium ions in the formula, you would put a 2 in front of moles of sodium plus ions. Okay, and then last step, same thing, multiply by Avogadro's constant. So this time we're going to use ions instead of atoms or formula units. Units are actually per mole, and this is just a 1-to-1. We call this the mole to mole ratio, often the key step in many chemistry problems. It's the same number, right, since that's just a 1. So 2.93 times 10 to the 22 ions of sodium plus.